Dear student, who are in class 11 and 12, CBSC, ICSC or WBC, HSC boards or council, and in future if they want to clear any type of competitive exam or NEET and JEE, it is quite helpful for you to understand in a simple and smooth way the organic chemistry. It is the class of organic chemistry class 11, but it is helpful also class 12 student. And if it is quite helpful to you, then kindly subscribe, view, and like my channel Monistry. The important topic here is isomer. Isomer of generally two types: structural isomer and stereoisomer. Isomers are those which having same molecular formula but different in function or structure, etc. So these are of two types: structural isomer and stereoisomer. Structural isomers are of different types such as chain isomer, position isomer, functional group isomer, metamer, tautomer, and the last one is ring chain isomer. And the stereoisomer is of two types. One is configurational isomer and the other is conformational. Here, configurational isomers are of two types. One is geometrical isomer and another is optical isomer. So it is geometrical isomer and one is optical isomer. Here, geometrical isomer means cis-trans isomer or EZ isomer or exo or endo isomer or syn and anti isomer. Later we discussed in my chapter in my channel all these isomers elaborately, but in optical isomers here we can we have discussed about homomer, enantiomer, and one is diastereomer. And for conformational isomer, these are of different structures such as elliptical, eclipsed. One is skew, another is anti or gotch, etc. All the total isomers covered in this class maximum. Such as first one is structural isomer. Give some example so that you can easily discuss and easily and smooth way you can understand. Chain isomer. Example of chain isomer is such as C4H10. Here the structure of C4H10 is there are something bond line structure. C4H10 we can simply draw this kind of a structure here, C4H10, but we can also write this. This means that CH3, CH2, CH2, CH3. This and this element is same, C4H10. But we can represent it in another way, such as like this: CH3, 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 CH. Here it is also seen that there are 4 carbon and 10 hydrogen. So this and this one, these are different in their names. It is called N-butane or normal butane, and it is called 1, 2, 3 means 2-methyl propane. These are called structural isomer, but especially it is called chain isomer. One example is C5H12. C5H12 having different type of chain isomers such as like that. It is normal pentane, that is 5 carbon atom present, so it is normal pentane. And the another is like that, it has also a 5 carbon atom, 1 2 3 4, and the other is 5, means CH3 CH2 CH2 CH3, and it is, sorry, it is CH and it is CH3, carbon having valency 4. And the another is, it is example of chain isomer of C4H5H12, that is CH3 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 and C. Here also 5 carbon atom present and hydrogen atom is 12. So they are structurally different, and especially they differ in their chain. So it is called, it has no branching, but it has one branching and it has two branching. It is called 1 2 3 4, means 2 methyl butane. It is called 1 2 3, means 2 2 dimethyl propane, and it is called N pentane. It is the then we discuss about case of positional isomer, that is C4H10O. The structure of C4H10O is that is CH3 CH2 CH2 CH2OH, C4H10O. And another is, here the position of the OH is indifferent, that is 1 2 3 4, and this OH, that is alcoholic group, is in one position. Here the alcoholic group is in two position, so the position of this OH are different, so it is called positional isomer. Let us draw another two isomers of C4H10O, that is like OH and 1 2 3 4, CH3 CH, sorry, CH CH3 CH2OH, and the another is CH3 CH3 CH3, that is 4 carbon atom present here, C4H10O. So these and these are not positional isomer, or these and these are not positional isomer. Here OH is at the side, and here also OH is at the right hand or at the side. So these are generally called one type of chain isomer. These are called chain isomer. Here the C4H10O, there are so many type of isomers, whether both 1 and 3 are chain isomer and 1 and 2 are positional isomer. Here 1 and 4 also a chain isomer, 3 and 4 also is chain isomer, but 1 and 2 is a positional isomer. Here the positional isomer and the chain isomer coexist here. The another is functional group isomer. Functional group isomer means here the functional group are different. Functional group isomer, let us take an example C2H6O. Here in case of C2H6O, CH3O CH3 or CH3CH2OH. Here the functional group, that is 3 4 5 and 6 3 3 6. It is called ether group. There is O present, means a ether group, and here a OH group present. OH means a alcoholic group. So functional group are different. One is ether and another is alcoholic. So it is called functional group isomer. There are so many type of isomer also present, that is C3H6O. C3H6O, here CH3C double bond CH3, that is C3H6O, and the another is CH3, CH2, CHO. It is called a keto group, and it is called aldehyde group. One is aldehyde and another is keto. These are different functional groups. So these are called functional isomers or functional group isomer. Another is metamer. Metamer means the another is metamer. Here metamer means the functional group is here same ether, and that is ether. Their structural formula is their molecular formula is same. That is C4H10O. There it is the molecular formula of C4H10O, and another is C4H10O. But it is similar in both the sides, but it is not similar. It is a asymmetrical structure. Here O, and it is C2H5. Here also C2H5 means it is similar. Both the sides have same number of carbon atom and same number of hydrogen. But here total molecular formula is same, but two different type of, here CH3 and here C3H7. The molecular formula is C4H10O in both the cases, but they varies in there it is dissimilar and it is similar. So it is called a metamer. And the another type of metamer example is C2H5, and the other side is C2H5. Here C double bond, that is a keto. And here also this keto group present, but it is dissimilar. One side is CH3 and the other side is C3H7. It is called metamer. Another is tautomer. Here generally an example of keto-enol tautomer, that is you see in all the books, it is CH3 single bond C double bond O, single bond CH2 single bond C double bond O, CH3. It is called acetyl acetone. It is called acetyl acetone. Means it comes from acetic acid. One part is from acetic acid, and that is another is from acetone, and it is called acetyl acetone. Here the keto from both the keto group is present, and the another term is, one is keto and the another term is enol. Enol means in, and the other is tautomer. Tautomer means that is generally so that keto-enol tautomerism, keto and enol form. There is keto group present C double bond O, and enol means double bond and OH, both are present. It is all and it is in. So in and all together enol. As example is CH3C double bond O, single bond CH2, single bond C double bond O, CH3. Acetyl acetone. Here the keto form, that is double bond O, C double bond O is keto form, and the another form is enol. Here double bond O comes here, and the one H goes to O. So it is CH3 C single bond OH, double bond CH, single bond C double bond O, single bond CH3. This enol form is highly stable in any type of non-polar solvent, and it forms a hydrogen bond, which is which creates its stability. It is 1 2 3 4 5 6, a six-member ring. Six-member ring. Due to formation of this six-member ring, it is highly stable. And one question arises from here, that which is more volatile, whether the keto form or the enol form. Enol form itself forms a hydrogen bond, that is called intramolecular hydrogen bond. It forms an intramolecular hydrogen bond. Due to presence of intramolecular hydrogen bond, it does not create any molecule or joint any molecule by any type of another hydrogen bond. It itself acts as an unique molecule. So the volatility is increased, that is separated easily. it vaporizes easily from its liquid phase to its vapor phase. That is, it cannot form any different type of molecules with hydrogen bond. It cannot participate another molecule with hydrogen bond because it itself creates a hydrogen bond and forms intramolecular hydrogen bond, which is its uniqueness, and it forms a unique molecule due to the unique molecular presence. So in vaporized vapor phase, it from its liquid to its vapor phase, it goes easily. And also it is that its boiling point also be very low. Its volatility is very high and boiling point is very low. Boiling point is the temperature required to break the bond between the one molecule attached with another molecule. Here one molecule is itself forms a hydrogen bond. It does not create any type of hydrogen bond to any type of molecule, same type of molecule. So energy does not so many required to break the bond, as it does not form any bond. So the energy does not required to break the bond, so the boiling point is decreases, and volatility or the increase in molecule in vapor phase, it is also increased as there is a low boiling point. Somehow energy is given to that, its molecule goes to its vapor phase, so volatility increases and boiling point is decreased here. It is called tautomere, and it is highly stable in non-polar solvent. In polar solvent, generally it is so that polar solvent hydrogen H2O forms a hydrogen bond to oxygen atom of K2, but it does not form any type of hydrogen bond to water molecule also, as it creates in itself an intramolecular hydrogen bond. So in non-polar solvent, it is highly stable and its contribution or percentage is maximum in non-polar solvent. Here the another and the last is ring chain isomer. Ring chain isomer. Ring chain isomer, it is the structure molecular formula is something C3H6. C3H6 means it forms a ring and also a chain, such as C3 CH3 CH double bond CH2. That is propene. That is propene, and it is also a three-member cyclic structure. That is a ring structure. It is called cyclopropane. Here also the molecular formula is same, C2H, that is C3H6. These two are called ring chain isomer. Another example of ring chain isomer is pent 1-ene. Pent 1-ene or pentene. CH3 CH2 CH2 CH and CH2. It is called a normal pentene. Its cyclic structure also present. That is cyclic structure is called cyclopentane. Another example of another structure is, it is called cyclobutane. Another is, here two carbon atom present, CH3 CH3 C C C. That is totally 5 number of carbon atom present. And another is here CH2 CH3 and the cyclopropane ring, and the other is CH3 CH3. There are 1 2 3 4 5 number of ring chain excluding the pent 1-ene, that is the chain isomer. And one question is here that for tautomer, which elements or which compounds show tautomer, which have C11O and CH3. CO CH3 group if present, then it shows a tautomer. means a C double bond O keto group having alpha hydrogen atom. Alpha hydrogen. Alpha hydrogen means the number of carbon which is directly attached to this carbon C double bond O is called alpha carbon. And if hydrogen present in that carbon, that is called alpha hydrogen. And the give some example of which equation arises whether benzaldehyde means benzene means CHO. It forms a ketonyl tautomer or not, or this type of structure forms tautomer or not. Here you have to find out whether any type of alpha hydrogen present or not. If it is present, then ketonyl tautomer shows, and if it is absent, then there is no ketonyl tautomer. Here the CHO group and the C double bond, say here the benzene and the CHO group, C double bond OH. Here the C double bond O group attached to this carbon atom, but there is no hydrogen present, so it have absence of alpha hydrogen. Alpha hydrogen, there is no alpha hydrogen, so it does not form any ketonyl tautomer. And here also there is no alpha hydrogen, as this carbon have no alpha hydrogen, so it does not form any type of ketonyl tautomer.